Hello, thanks for your question. So, first of all, we have stock A and stock B, and I changed the numbers uh, because this will be public, and yeah. So I did change the numbers, but this is still going to be a very similar problem to what you submitted. So instead of 10 for stock A and 50 for stock B, it's 8 and 40. But still, we're using the same numbers for everything else, right? Still, we have three portfolios going to be labeled A, B, and C, and we'll see more of that below. But with portfolio A, it's 100 shares of stock A. Portfolio B is 50 of A and 10 of B. And then portfolio C would just be 20 of B. And then associated with stock A, we have a profit of X percent, and stock B, a profit of Y percent. And X and Y, of course, have variability. They can change with different probabilities, right? And so the question is for us to find the EV and the variance of the profit. So first of all, what is expected value and what is variance? Expected value, first of all, is pretty simple. It's the profit times the percent probability that you'll get that profit. So if I have if I have a 10% chance of making $100 and a 90% chance of making nothing, then my expected value overall would be about $10 because it's a 10% chance of making $100. But most of the time, I'm not going to make anything. So it balances out to $10 expected value. That's pretty much what it is. And the formula for it, for EV, is going to be the sum. And what I have here, I can explain the different variables. I have P. This little p represents a variable that contains how much profit you're going to get. And then big P is the generic signifier, the generic, like, I guess, symbol for probability. And then it's the probability of whatever's inside the parentheses here. It's the probability of the amount of profit being equal to that value P. And for each different P that we have that has a certain probability, we're going to multiply that amount of profit by the probability, and then we're going to take all of those and add them together. And that's why we have a sum. Okay, and the second thing we have is called variance, which there's just another formula. Essentially, variance measures how much is like spread out. And this is also sort of like useful for, I guess, just groups of numbers in general. Like you can have groups of numbers that are super compact and like most of them are centering around a certain range, and then you can have super like spread out ones. But this is also a different version of variance for stuff with probabilities, which is what we're talking about here. I did write this wrong. It's actually squared here. So the formula is the summation of P minus mu squared times the profit, or the probability of the profit being P. And by the way, mu is the expected value in this case. It's just the average value. The expected value and the average value are basically the same thing. Because the expected value is really just like an average value of what you will get in the end. So the variance is this formula right here. And we'll see how that actually plays out in just a second. So now that we've talked about the definitions of everything, let's go to the first step, which is converting X and Y to profit, meaning taking the values the problem gives us for X and Y and converting that to how much profit you'll get. So we know that X and Y have different values based on how lucky you are, right? If you get unlucky, for example, if you look at the problem, you have a 0.3 chance, so a 30% chance of getting -3 for X. You have a 0.4% chance of getting -3 for Y, which is like being unlucky. But fortunately, we have a slightly higher chance, 60% in the case of Y, for a gain of 3% profit, right? So basically, that's like the chances. If you're unlucky, though, X and Y are lower, but if you're luckier, they'll be higher. But what we're interested in is profit, not X and Y. They give you the percent profit. We have to convert to profit first. So to convert to profit, we just use this like very intuitive formula. It's the percent profit over 100 because it's percent but then we just times the number invested, or the dollars invested, and that gives the total profit, right? So, for example, and we can just go through portfolio A, B, and C. With A, in our case, since we're buying 100 shares of stock A and it's $8 a share, we've invested 800 in stock A. And the profit would be whatever X is divided by 100 times 800. And that simplifies to 8X. So in portfolio A, our formula for profit is going to be 8X. Portfolio B, we're going to do something similar. We can calculate based on how many stocks of each A and B we have, that we're going to be investing 400 in stock A as well as 400 in stock B. And when we take that all together, the profit is going to be whatever X is over 100 times the 400 we have in stock A plus whatever Y turns out to be over 100 times that 400 we have in stock B. And all together, we're going to get 4X plus 4Y. And that is the formula for portfolio B for the profit. And a similar thing for C, except instead of X, we have Y, because this time in C, all of our money, $800, obviously the numbers are changed, and yours is 1,000. But in this one, all 800 are going to be invested in stock B, meaning our profit is dictated by how lucky we get with Y. And the profit is calculated by Y divided by 100 times 800. And it simplifies to 8Y. And that is our formula for portfolio C. So now that we have all these formulas, we have to do the probability distributions. And then after that, we can very quickly get our answers. And this is basically the rest of the problem right down here. Now, I didn't write out every single number because it's a lot of numbers, and they're not even the same as yours. So yeah, but it should be very similar. When you rework it and do all the numbers, it should be very similar. So starting with portfolio A, I made this little table, and it shows the probability of each number X and the corresponding profit. Ignore the 10. It's 8X there. Definitely 8X. All right. So there's a 30% chance probability, first of all, that X is -3. And again, this is when you get unlucky. And X being -3 translates to a profit of -$24, meaning you actually lost $24. With a 20% chance, also, we have no change. X equals 0, meaning a profit of 0. You break even. And then a 50% chance of gaining $24. And we see that we use, since this is a portfolio A, we use this formula for 8X to convert from the different values of X to the different values of profit. But we still have to keep in mind the probabilities. That's why I listed it in this table. And now that I have this table, the rest of the problem is pretty easy. We just use the formula for expected value, which is, it's the amount of money times the probability that you get that amount of money. And then you add all the different amounts up times their respective percent probabilities. And in this case, it's going to be -24 times 0.3, because that's the first one in the table, that's the first in the list, times its respective probability. And then we're just going to take that, and we're going to add the second one, the second row, right, 0 times 0.2, and we're going to add the third row, 24 times 0.5. And altogether, we get a value of 4.8. This means, on average, you will gain $4.80. Again, with the numbers that I changed it to. This is not going to be the same answer you get. Just keep that in mind. And on this one, it's not 6. It is 4.8. Don't know why I said 6 there. But yeah, also keep writing 6. It's not 6. It's 4.8. And the rest of it's 4.8, right? So yeah, this is variance. And remember what I said at the very beginning, the mu that I have in the formula is actually just the expected value, which we just got from above, 4.8. And we plug everything into the formula, and we have the same thing. First of all, if P is -24, that's a probability of 0.3. You plug that in, -24 here, minus 4.8 squared, times the probability. Again, that is just P minus the expected value, take that squared, times the probability of that specific P. Same thing you see here. Then we add for all the different P's and their respective probabilities. This one is 0 minus 4.8 squared times 0.2. And this one is 24. This is the luckiest case. If you get p of 24, we're going to take 24 minus 4.8 squared, multiply that by its probability of 0.5. And then you can simplify that. I didn't write it out because it's like, again, it's not the same numbers, and I didn't feel like taking my calculator. So, yeah, but that is the process. The last thing I really want to cover in depth is portfolio B, because actually I'll just scroll down to portfolio C. It's very similar to A. It's just Y instead of X, and we have a slightly different table. Oh, whoops. We have a slightly different table right there, right around here. And you can see the differences. EV, the same formula. We do the same procedure for that, and coincidentally, we get the same value. That's a complete coincidence, right? And for variance, we're going to do the same procedure using our new table, and that's portfolio C. So C and A, portfolio A and portfolio C are very, very similar. And you should be able to look at the portfolio A, understand that, and then easily do C. Okay, but let's talk about B for a second. B is a lot, it's a little bit, it's definitely harder than either of the other ones, because if you look back at if up here what we figured out, our equation is actually 4x plus 4y, meaning the profit depends on two variables, which is going to be harder than just one. So what I did here was I wanted to show you exactly how I got all the numbers I got. So what I did was I took the different possible values for x. Remember, x could either be -3, 0, or 3. And then y, I put x on the top one, and I put y on the left, going down. And y could also either just be -3 or 3. Can't be anything else. And then for each combination of x and y, I found the probability because these are going to be independent events, meaning for example, the probability of x being -3 and y being -3, since they're independent of each other, what you do is you multiply the probability of each to get the overall case. So since x and y are independent of one another, 0.3 times 0.4 gives you the probability of x being -3 and y also being -3 at the same time. Gives you 0.12. And I did this for every one of the cases. For x to be 0 and y to be -3, I multiply the probabilities of each of those events together since they're independent, and I get 0.08. I did the same thing for all of these cells. And so each of these cells represents one possibility and the associated probability of that event happening, of that cell happening, right? On the right table, we have the exact same table. It's identical. But instead of on the inside, instead of the probabilities, I'm giving the values for the profit. Because at the end, remember, we want to link profit to the probability of that profit happening. Because we're interested in the probability of distribution of the profit. So what I did was I just calculated all the values. So you can see how I did that. 4x plus 4y on each of these cells, and I got those numbers. And again, your numbers will be different. And then what I did was I just put them all together. This cell gives you a profit of -24 and has a probability of 0.12. And no other cell gives you a profit of -24, meaning this is the only way to get -24, meaning the probability of getting -24 profit is just 0.12. And that's what I put on the first row. So I'm going to combine these two tables and put them in this main table down here, just profit and probability. The only trick here, you notice this row is actually different than all the other rows because there's two different probabilities added together, and that's because two of the different cells actually had a 0 profit, and so I had to add the probabilities of both of those happening together to get the total probability given all the different possibilities of cases where the profit ends up being 0. And that's going to be a total of 0.38, 38% chance of getting 0 profit overall. And now you see this is the same thing we had in portfolio A and portfolio C. It's just a table with the profit listed and the probabilities. And so to find EV, well, we just go row by row, like we did in the other ones. And I'm sure you can see at this point where I got this. So it's, again, each row you're going to do P, which is the profit value, times big P, the probability function of that profit being that same value. Like in this case, it's a 0.12 chance, or 12% chance, that profit is negative 24. I take that negative 24 times 0.12, and then I add all the other rows, each one by one. And by some crazy coincidence, I don't know how, I guess this is probably the way the problem was designed. It's also 4.8. I mean, maybe I did it wrong, but yeah, that's a crazy coincidence. But then variance, again, you've seen the process before. Just take each row minus the expected value, again 4.8, and that comes from this 4.8. If it was a different expected value, these numbers would all be different as well. And then take that squared, multiply by probability, do the same thing. Notice the 0.38 here from that third row. But yeah, that's basically it. I hope that made sense. I hope that cleared a lot of things up. And yeah, again, remember, I changed these numbers. I didn't change anything else. So just change the numbers and redo the problem at each step. And yeah, you should be good. Hopefully that helps. Thanks for watching.